Hello, I'm Kiran Kumar from Nature of Physics. Today topic is displacement current from the electromagnetic waves. Please watch full video, you will get clarity, and please do like and subscribe our channel Nature of Physics. See student, considering a parallel plate capacitor of capacitance C, each plate area A is equal pi r square. This is the positive charged plate and this is the negative charged plate, and this is connecting to the battery potential V student. So this current is taken as conducting current IC, and this current is taken as displacement current in the capacitor student, and this is outside the capacitor is taken as conducting current student. This is also taken as conducting current. Only between the capacitors we are considering the displacement current ID. Okay, IC is the conducting current outside the capacitor, ID is the displacement current inside the capacitor. So Maxwell Ampere's law, closed integral b bar dot dl bar is equal mu naught ID plus IC student. Okay, J is the current density. So current density nothing but current per unit area. So first equation I am going to write for the conducting current outside the capacitor. J is equal to IC divided by pi r square, where r is the radius of the wire student, and J current density for the capacitor writing student, that is displacement current divided by pi r square. Here small r represent the radius of the capacitor plate student. And so current density is remains constant, that's why both equations are balancing student. That's why I can write ID by pi r square, which is equal to IC divided by pi capital R square, so that pi is get cancelled. Next I am going to get ID displacement current, which is equal to IC into small r square divided by capital R square. This is equation number 1. So Maxwell Ampere's law outside the capacitor and Maxwell Ampere's law inside the capacitor we are going to discuss student. So first Ampere's law I am writing closed integral b bar dot dl bar is equal mu naught IC. So b common student, integral dl is equal to L, so that length of the wire is taken as 2 pi r student. Integral dl is equal to L is equal to 2 pi r, L length of the wire bent in the form of circular shape, so that which is equal to mu naught into IC student. So that magnetic induction B, which is equal to mu naught IC divided by 2 pi r. This is I am writing as equation number 1 student. Okay students, so this is I am representing with Roman number 1 student. Next, Maxwell Ampere's law inside the capacitor writing, that is closed integral b bar dot dl bar, which is equal to mu naught ID writing student. D is the ID is the displacement current, so that B into integral dl is equal to L value is written as 2 pi r, which is equal to mu naught ID student. So that B, which is equal to mu naught ID divided by 2 pi r student, this is written as Roman number 2 students. And continuation here, equation 1 is replacing in this equation, so that we will get B, which is equal to mu naught divided by 2 pi r into ID value is written as IC into small r square divided by capital R square. One small r is get cancelled, so finally I am writing here student B, which is equal to mu naught IC divided by 2 pi into small r divided by capital R square student. Okay, this is I can write as equation number 3. Now charge Q is equal to CV. So C value is equal to parallel plate capacitor A epsilon naught divided by D student, and EVD relation writing E is equal to V divided by D, so that I can write V is equal to ED student. Now both the values are replacing in the above equation, so that Q is equal to CV value, C is equal to A epsilon naught by D, and V is replaced by EVD relation, V is equal to ED student, and DD is get cancelled. And next step I am going to write there q which is equal to a epsilon naught into e student. This is the charge equation. So that rate of flow of charge is called current student. From this equation, dq by dt which is equal to d by dt of a epsilon naught into e student. Both side differentiation with respect to time I did student. So that dq by dt give the current I which is equal to a epsilon naught is the common. So de divided by dt I got. Now I can write this is equation number 2 for the displacement current id student. See there, id is equal to a epsilon naught de by dt is the second equation. And continuation, there is a relation student in which first I am going to write the electric flux phi E which is equal to EA student. From this, E is equal to electric flux divided by area student. E is replacing in the above equation. Then the displacement current ID which is equal to A epsilon naught d by dt into phi divided by A student. So in this area A is common student, so that I can write ID which is equal to A epsilon naught by A student, A epsilon naught by A common, and d by dt of phi. And continuation, here A is get cancelled. ID is the displacement current which is equal to epsilon naught into d phi divided by dt student. This I can write as equation number 3 student. Okay, and in this equation also we can replace displacement current ID which is equal to epsilon naught phi divided by t writing student. Okay, ID which is equal to epsilon naught phi value is written as EA divided by T student, and ID which is equal to epsilon naught E value replaced by EVD relation, E is equal to V by D, and remaining value is A divided by T student. This is equation number 4. Different displacement current equations I am writing here student. And continuation, next one is here, this is the second equation in which E value replacing E is equal to V divided by D. From the equation number 2 I am writing student. So that ID which is equal to A epsilon naught d by dt of V divided by D student. In this equation, ID which is equal to A epsilon naught by D denominator is common, dV divided by dt student. Now I can write this is equation number 5 for the displacement current student. And also here C which is equal to A epsilon naught by D student replaced in the above equation, so that we will get final equation for displacement current ID which is equal to A epsilon naught divided by D value is written as C student. Again I will write dV by dt, so that ID which is equal to C into dV divided by dt student. This is I can write as equation number 6. 6 different equations I gave you for the displacement current. This is the clear information about the displacement current student. Please do like and subscribe our channel Nature of